Hello, what's up guys? Today I'm gonna show you how to make a subwoofer circuit. We are gonna need a step down transformer 12 by 2 volts 1.2 amperes. We are gonna need an output speaker that is 30 watts by 4 ohms. We are gonna need amplifier IC, some ceramic capacitors, some resistors, operational amplifier which acts as our low pass filter. We need 2 capacitors, each of the 300 microfarads, 25 volts. We also need some smaller capacitors, that's bipolar capacitors, one of 1 microfarad, the other one is 4.7 microfarad, both of them at 50 volts. We are going to need some resistors to couple in our circuits. Then we are going to need our bridge rectifier over here. Here it is. Let's get rolling. First of all guys, we need to identify our outputs and be careful not to solder the wrong wires on the wrong points, because this can cause a blow to the capacitors. We need to have a reference ground which acts as the reference between the positive voltage and the negative voltage in our amplifier. So here we need to connect our capacitors in this design. Then we can have them soldered to give a neutral point, and there you go. So they look something like this. So we have one negative and one positive terminal, both connected together. So the other edge gives us our negative voltage and positive voltage. The next point is trying to trace our AC and try make it DC so that we can feed it into the capacitors. And here in between these central terminals here, we got our AC inputs, DC outputs at the ends. So there we go. We now have our AC connected at the center point of the encapsulated bridge, and we are going to obtain our DC, that's our positive voltage from the notched end, and our negative voltage from the other end. Now here we come, we get our positive voltage right from this terminal here, and get our negative voltage right from this terminal here. So now this end to end will give us something to do with up to 40 volts, at least that 6 volts when pass through the capacitors. Without the capacitors, we are gonna have something to do with 25 volts. I have used a blue wire for my positive voltage, and my negative voltage goes with a black wire. So we are gonna connect them to the capacitors, and then this central wire over here that was left out during the bridging, we are gonna feed it to the center point of the capacitors to create our grounding. So there we go, connect our negative voltage over there. We are gonna connect our positive voltage over here. Then we're gonna have our grounding point. Comes right from the center top of the transformer and to the central point of these 2 capacitors over here. There you go. Now with this, we have our full supply of our circuit, end to end, about 40 volts, and the grounding as the reference point of the negative voltage and the positive voltages. From there guys, we are gonna fix our ICs onto the heatsink. Here we have the amplifier IC and the operational amplifier or the low pass filter. We are we are gonna have them screwed so that they fit and they are tied on to the heatsink for maximum power dissipation. So make sure your IC is tight so that no airspace between the IC itself and the heatsink. This ensures maximum heat dissipation so that the IC can remain cool during operation. The next thing, guys, is fix our components. Now we are going to start with the low pass filter circuitry so that we can assemble it. Then we can thereafter come to the amplifier itself and then couple them. Make sure your terminals to these ICs are neat and are free from short circuit so that we don't damage our circuits. You can start by tinning them so that the soldering points are clear and free from oxidation. Yeah, now they are ready for soldering. We are gonna start with this ceramic capacitor, which acts as a feedback input between pin 1 and 2. There you go. Here you have it. So it is pin 1 and 2. We are gonna have this resistor. This reads it's red, orange. That gives me 22 kilo ohms. We are gonna have it fixed there. We are gonna terminate it together with this capacitor here, like that. We are gonna have this 100 kilo ohm resistor at pin 7 and 6 across pin 7, right there. Now we are gonna loop it to pin 6 right here. So from pin 6 we loop a wire from pin 6. Oh, sorry, we have so as you can see, we have this resistor coming from pin 7 all the way looping to pin number 6. The other ceramic capacitor loops from pin number 4, pin number 3, sorry, there, and it loops to pin number 5, which helps in the discharge of the stray audio. So we get it at pin 5. There you go. And the capacitor over here. There you go. The other step is trying to have the right gate and the left gate of the op-amp having one common channel, and this is achieved by simply including a resistor right here. Then it loops all over to pin number 7. There you get them going like that. Now the final step, the op-amp is connecting the voltages as a negative and positive voltage via a resistor of 470 ohms. This prevents overcurrent or over any surge due to voltages. Number 8, here you have the positive voltage and solder it there, 470 ohms. Can have Then we have the other voltage, the negative voltage at pin 4. There you have it. Now guys, we have our op-amp assembled, or our low pass filter assembled. Now we are gonna skip to or move now to the the amplifier itself, and we are gonna configure it with the components, and let's see how this goes on. First of all, we are going to prepare the pins for neatness and for easy soldering. First, we are gonna have this capacitor. This is the voltage capacitor that I see for smoothing voltages. We are gonna have it soldered across the negative, the positive voltage between pin 3 and pin 5, and here they are. For clear visibility, I'm gonna turn this heatsink like that. We are gonna have our feedback resistor at the output pin. It's pin number 4, and feedback to pin number 2, which of course is the feedback pin, or in other words the turbo of the IC. There you have it. These 22 kilo ohms, you can have a range of 22 up to 30 kilo ohms. This will function. From this point, we have the discharging path, which is created by having a resistor of 560 ohms. There you go. Connected a capacitor. This is 50 volts at 1 microfarad. Can have it there. So here we get to our final touches of having our output resistor for regulating the impedance of the output and the resistance of the IC. So guys, here is our complete circuit, and now we are gonna have the power feeding point. From there we are gonna test our circuit. Guys, now here we have our looping voltages from the high voltage, negative and positive voltage, but the grounding from the major amplifier IC to the op-amp or the low pass filter, because they need to share the same voltage or the same grounding for the common grounding of the audio, because it passes through the same circuit simultaneously. Here guys, we need positive input, negative input, and the neutral ground. So I'm gonna have 3 conductors, one the negative voltage, the other one the positive voltage, the other one the grounding. And here we go. We connect the negative voltage, positive voltage there. Then the common ground, because you can have it there. From there we can now feed the voltages, starting the negative voltage from, of course, our main source or supply as the capacitor point, and there you go, positive voltage, here you have it. And then we have the common grounding, which comes between the two capacitors here, the common point. You can have it there. There you go. Here comes now the coupling, guys. We have to put the input to the major amplifier from the op-amp or the operational amplifier, that is the low pass filter. So our output is from number 1 to somewhere there. Get it there. And bring it to the input as pin number 1 of the 23 IC of the major amplifier IC. Then, guys, we have our audio input that checks through a capacitor, 50 volts, 1 microfarad. There you get it. This is our audio source, guys. We're gonna have an AUX cable from the audio source. We can have the audio input, positive input, the capacitor there, and the other one is the grounding, the neutral grounding, not the positive or negative voltage. Guys, we are gonna connect our speaker now, and we have the positive side of it coming at the output of IC via the resistor, and there you got the terminal. Then the other end of the speaker, we are connected to the grounding. Remember, the grounding does not mean negative voltage. Hey guys, we are done with the assembly. We are now already testing the circuit, and we want to hear how it will respond. We have a phone audio source, and we have it connected to the circuit. Let's see this. See this, guys, you put it in an airtight container or maybe a cabinet, it will sound great. Having it right there, it has worked perfectly. That was output at Roaring Smart. You need a cabinet and you want to fix it there. It's gonna sound a little bit different with its maximum bass. Remember, this is a low pass filter and it only acts for the bass channel. If you want to add some mid-ranges, you're gonna have different channels acting on different ICs. There you have it.
Ega Subwoofer kuraguza.